Assuming you drew it B down in this picture, you should get negative 400 for B. Right, which means your value of C should be how much? Right, the way I drew it, positive 400. Right, then coming over to picture 1, what do you get for your value for A? You get 1,000 newtons. And for the moment at A due to the wall, right, positive, at least the way I assumed it, positive 2,800 newton meters. Again, going back to when we did this in 211, I arbitrarily assumed that MA was a positive moment. A could be up or down. I assumed it was up. C had to be up. And B, I arbitrarily assigned in this picture up, which means in this picture it had to be down. So between the two free body diagrams, I could solve for the 4 unknowns here, sum of forces y, sum of moments, to get these 4 unknowns. We're going to copy the entire thing and now apply our knowledge of what the external loads are. So when we put it back together, we can't see B anymore, but the fact that it's a compound beam we will be able to observe from the VM diagram. Right, so when we put it back together, at A, I have the moment from the wall acting on it, 2,800 Newton meters. A was up 1,000 newtons. I have the point load of 600 newtons, 2 meters away. Again, B is hidden, or I guess B is here. And finally, I have the point load at C, which we found to be positive 400 newtons. I need to make lines where that point load is, where the start of the distributed load is. And then that's already at the edge, and the moment and this 1,000 newton is already at the edge. Right, so in the M diagram, first we want to add this critical line where the V diagram crossed 0 over here during that distributed load. The M, we immediately jumped down by 2,800 because of that couple on the wall. So externally positive, which means internally we jump down to 2,800. Add 2,000 to that horizontal line, so this is a first order line. Add another 800, we go back up to 0. Again, by a horizontal, when we integrate, it becomes a first order line. Up here, we're going to go up to 200. Again, the concavity, we look at the V diagram to determine. It's going to start with a positive slope of 400, and it's going to go to a slope of 0 at the maximum. We're at 200. By the next line, we lose 200, and we go back down to 0. We start with a slope of 0, and we end with a slope of negative 400.